Hello students, a good day to you and you're welcome to this video on mensuration. Now this video will focus on answering questions and then giving you some more work to do. You'd remember that in our last interactive class we started out with mensuration and you were taught a number of things under this topic. And you were given certain exercises as well, which some of you sent in, and I'm going to be using that as a basis as we go into this particular video for today. This video is for grade 10 class, and I want to say you are all welcome. Now we have one giant objective for this video, and it is to solve practical problems on mensuration. So basically we're going to focus on questions and then trying to solve them so that you can be prolific in your ability to answer questions on this topic. And these were the exercises that you were given in our last interactive class. There were 7 of them. And I want to appreciate those of you who did the work on time and sent the answers in. You're the ones who have given me a picture of the questions that you have understood, the areas that you have understood, and the ones that you might still need a little bit of explanation on. So out of these 7 questions, to a large degree, most of you did well. But I thought that there would be need for me to go over questions 3, 4, and 7. So in this video, I'm going to solve questions 3, 4, and 7. And then afterwards, maybe an example or 2. And then I'll give you another set of exercises to gauge how well you have understood the concept. All right, so we will start with the third question. Which is this. It says that the length and breadth of a rectangle are in the ratio 3:2. If the area of the rectangle is 726 centimeters squared, find its perimeter. Now, some of you didn't understand this question very well, because you didn't take note of the fact that what we are given is the ratio of the length and the breadth, and that implies something. So the length of the rectangle will be 3 times x, and the breadth of the rectangle will be 2 times x. Why is that so? Because ratio implies that a division has been performed to its lowest terms. So the length of the rectangle is not 3. Neither is the breadth of the rectangle 2. But that is the ratio of the length to the breadth. That is, there are 2 values that had been divided to their lowest terms that gave us 3 and 2. Now, if I would make that visual for you, look at this example on your screen. If you have 20 divided by 12 or 20 over 12, now obviously that can be splitted to be 5 times 4 in the numerator and 3 times 4 in the denominator. Of course, 4 in the numerator and 4 in the denominator can cancel out, and then you have 5 divided by 3, which is the same as 5 ratio 3. So I could say that something was shared in the ratio of 5 to 3. And yet it doesn't mean that the number is 5 or the number is 3, because you can see clearly from this example the numbers are 20 and 12. But then when they are brought to their lowest terms, they became 5 ratio 3. So what that implies is that the 3 ratio 2 that we are given for the rectangle has a particular constant divided from both the numerator and the denominator. It is that constant that we are representing by x. That's why the length is 3x, because there is something that must be multiplied by 3 that will give us the value of the length, and the same thing must be multiplied by 2 to give us the value of the breadth. Like in this example, that would be 4. 5:3, if you want to get the original numbers, you multiply both the numerator and denominator by 4, and then that will give you 20 and 12. So in the same vein, our length is 3 times a particular constant, and our breadth will be 2 times the same constant. Now from the question, we are also given the area of the rectangle. The area of the rectangle is 726 centimeters squared. Now if that is so, we know the area of the formula for the area of a rectangle to be length times breadth. When you multiply the length of a rectangle by the breadth of that rectangle or the width, then you have the area of that rectangle. It means that if I multiply the length, which would be 3x in this case, by the breadth, which would be 2x in this case, I'll get the area, which will be 726. Okay, so I have made a mathematical statement out of this word problem, and of course 3x multiplied by 2x will give me 6x squared, which will be equal to 726. From here, I believe you can find your way to to the answer. You're going to divide both sides by 6, so x squared will be equal to 121, and then you find the square root of both sides, which will leave x to be equal to 11. So if x is 11, it means that the length of the rectangle would be 3 times 11, which would be 33 centimeters, and the breadth of the rectangle will be 2 times 11, which will be 22 centimeters. Now the question tells us to find the perimeter. It means that our work is only half done. We're not required just to find the length and the breadth of the rectangle, but to find the perimeter. And that means that we're going to have to use the formula for perimeter of a rectangle, which is 2 into bracket length plus breadth. We had the length to the breadth, and then we multiply that by 2, and that will give us the perimeter. So we can insert values: 2 into bracket 33, which is the length, plus 22, which is the breadth. And then we solve the bracket. That would be 55 times 2, and that would be 110 centimeters. So the perimeter of this rectangle will be 110 centimeters. So this is how to set up your work. This is how to get this done. Some of you didn't get it right, okay, but some of you did as well. But this is what to do. Okay, so let's go back to our home page, and like I told you, we will also answer question 4 in this video. So question 4, here we go. It says there are 2 parts of width 2 meters each in the middle of a rectangular garden of length 80 meters and breadth 60 meters, such that one path is parallel to the length and the other is parallel to the breadth. Then it says find the area of the paths. Some of you got this right as well, but some mixed things up somewhere along the line. Okay, so first things first, we do have a rectangle. A rectangular garden, okay, and this rectangular garden has a length of 80 meters and a breadth of 60 meters. Okay, so we have that already. Then it says that there are 2 parts in the middle of this rectangular garden, and one of the parts is parallel to the length. So we could have something like this, which is a path in the middle of the rectangle that is parallel to the length of the rectangle. So we have this path, which is 2 meters wide, and then we have the other path, which is also parallel to the breadth. So we have these which is also 2 meters wide. So let's put those in: 2 meters wide here, and then 2 meters wide on the other side as well. Now we are required to find the area of the parts. We're required to find the area of the parts. Well, the area of the parts will be equal to the area of our horizontal rectangle, that is our horizontal path, plus the area of our vertical rectangle, which is our vertical path, and then we'll subtract the area of their point of intersection. And there's a reason we are going to have to do that. As a matter of fact, the mistake that some of you made was that you did not subtract the area of the point of intersection from, the summation of the areas of the path individually. Now, if you look at this path right here, we will find the area of this path or rectangle. And when we are done with that, we will also find the area of this other path or rectangle. But there's something you should notice, and that is the fact that we have counted this area twice. When we were dealing with the area of the horizontal path or rectangle, we counted that part. It was part of the area that we counted. And then when we went through the vertical line as well, it was also part of the area counted. So we have counted that point twice, just like the point of intersection in your set theory, if you remember that. Okay, we have counted it twice, and so for us to get an accurate answer, we have to subtract that area once, from the summation of the other areas of these rectangles. Okay, so the area of the paths will be the area of a horizontal rectangle. We know that area is length times breadth. The length of the horizontal rectangle right here is 80 meters because it's just the same length as the length of the main rectangular garden. So that the length is 80, and the breadth, which is the width as well, is 2 meters, just like we were told in the question. So 80 times 2 will give us the area of the horizontal path or horizontal rectangle. And then for the other rectangle, the vertical one, the length of that would be 60 meters, which is parallel to the breadth of the garden. So you have 60 multiplied by 2, which is the width of that as well. So you have 60 times 2. And then we're going to subtract the area of our point of intersection. And this point of intersection is a square. And the length of the square is 2 meters. You can see that length right there. Okay, because it's the same size as the width of the rectangle. And then the breadth is also 2 meters because it's the same size as the width of the other rectangle. So that'll be 2 by 2. It's a 2 by 2 square. That's the dimension of that square in the middle. So if you have this, 80 by 2 is 160, plus 60 by 2 is 120, and then minus 2 by 2 is 4. 160 plus 120, that would give us 280. And then we subtract 4 from that, will give us 276 meters squared, because, well, we are talking about area, and our area is always in units squared. Okay, so this is just what you were supposed to do in this question, and I think that it is not really difficult. You only need to understand the concept, and then you apply that. Okay, so we'll go back to our home page so that we can answer the last question from this page, which is question 7. We're going to answer question 7 as well. And that says that around a circular park of radius 21 meters, there is a circular road of uniform width 7 meters outside it. Then it says find the area of the road. So we have first and foremost, we have a circular park. We have a circular park like that, and the radius of this circle is 21 meters. So the radius is from the middle of the circle to one part of the circumference, any part of the circumference, and that's 21 meters. Okay, and then it says also that there is a circular road outside this circular park. So you have this road like that, which is obviously bigger than the park. All right, just goes around the park like that. And the width of the road is 7 meters. The width of the road is 7 meters. So right there you have the width, which is 7 meters. Okay, which is the distance between the park and the end of the road. Okay, so the road is just like that, 7 meters all around the park. Now we're supposed to find the area of this road. And that is fairly easy to do. You see, because the area of the road, which will be the space right there, the space right here, will be the area of the larger circle, this circle right here, the larger circle, minus the area of the smaller circle, the one right here in the middle. So the smaller circle is representing the park, the larger circle is representing the end of the road. So the road is from the end of the park to the end of the road, and that's what we have to find. So if we can find the area of this larger circle and subtract the area of this smaller circle, then obviously what we would have would be the area of the space between them, which is the road. Okay, but before we are able to do that, we need to remember that the area of a circle is pi r squared. So the larger circle we would represent by this capital R, and the smaller circle will be represented by this small r. So the area of the road will be pi big R squared minus pi small r squared. Okay, and next thing we have to do is to find the radius of the big circle or the larger circle. Now we have a 7-meter space right here, and but that's not from the center of the circle. If we draw straight down from the center of the circle, which will form the radius, you remember that radius is any line from the center to one part of the circumference. So this will form the radius of this large circle. Okay, but obviously for the smaller circle we have a radius of 21 meters, and we know that the radii are equal in any direction that they are pointed. So it means that this radius here for the smaller circle will also be 21 meters. And if that is so, it implies that the radius of the larger circle will be 21 meters plus 7 meters, which will give us 28 meters, because it's just a continuation of that. All right, so we'll insert values. We have pi times 28 squared, which is the radius of the larger circle, minus pi times 21 squared, which is the radius of the smaller circle, and that will give us the area of our road. Here our pi is common, and then we'll have 28 squared minus 21 squared. Okay, and we can use the difference of two squares, so we'll have pi into bracket 28 minus 21, and then we'll close that bracket, open another one, 28 plus 21. Okay, and then if you press your calculator, you have 1077.706 meters squared, which of course we can bring down to a whole number. So the area of the road is 1078 meters squared to the nearest whole number. All right, and this is also quite easy. All that you needed to do was to have an idea how to draw the diagram, and then what the radii of each of the circles will be, and this just hit right here. So we'll return to our home page, and then we'll see if we can do an example or two before we call it a day. All right, so we'll go to examples, and right here I have my first example on the screen. It says, on a square shaped handkerchief, 9 circular designs, each of radius 7 centimeters, are made as shown in the figure. So it says find the area of the remaining portion of the handkerchief. So we have this handkerchief, which is a square, and there is a pattern drawn inside of circles, 9 of them, and each circle is of radius 7 centimeters. But we can see these spaces here, the remaining portion of the handkerchief, and the question says we have to find the area of that portion. Now that's easy to do. All you need to do is to find the area of the square. If you know the area of the square, subtract the area of the 9 circles from the area of the square, and then you have what's left. And I hope you understand that. Okay, so the area of the remaining portion of the handkerchief would be equal to the area of the square minus the area of the 9 circles. Okay, now obviously we know what the area of a square is. It is the length raised to power 2. That is, if we can know the length of one of the sides of the square, then we just raise that to power 2, and then we have the area of the square. And of course we also know that the area of a single circle is pi r squared. We'll find the radius, and then we multiply that by itself and multiply that by pi, and that will give us the area of a single circle. But there are 9 of them, so we have length squared, which is the area of our square, minus 9 pi r squared, which is the area of 9 circles that are drawn in these square-shaped handkerchief. Now, for us to be able to find the length of these, handkerchief, we have to notice one important fact that the question told us. It says that the radius of each circle is 7 centimeters. Now we know that the radius is any line from the center of the circle to any part of the circumference, and it means that from somewhere here, which is the center of this circle, to the circumference is 7 centimeters. But we also know that radii are equal in any direction. So it means that if we begin from the center of this circle to the other part of the circumference, it will be another 7 centimeters. I'm sure you are well aware of that. The diameter of a circle is 2 times the radius of that circle. So it means that the diameter of this circle is 14 centimeters, which is the same as the diameter of this circle and this circle. All 9 circles have the same diameter. So if I look at the first 3 up here, from this circumference to this part of the circumference of the first circle, it's 14 centimeters. Now, as soon as I enter into the second circle, from here to this part of the circumference is another 14 centimeters, and then from that point to the end of the circle is another 14 centimeters. So it means that the diameters, if I combine the diameters of these 3 circles together, it will give me the length of the square. Do you understand? To give me the length of the handkerchief, because right from here down here, it will give me a line that is parallel to the length of the square, and that line will be parallel and equal to the length of the square. It means that the length of the square would be 14 plus 14 plus 14, and that will give us 42 centimeters. So the length of the square is 42 centimeters, and the radius of the circle is 7 centimeters. Alright, so we insert values into this equation right here. The area of the square would be length raised to power 2, which is 42 raised to power 2, minus the area of the 9 circles would be 9 times our pi is 3.142 times our radius is r, is 7 rather, and then we square that to give us 49. So if you insert those values into your calculator, your final answer will be 379 centimeters squared. So the remaining portion of the handkerchief has an area of 379 centimeters squared. I hope you understand that, because it's fairly easy. Okay, so let's look at one more example before we round up. Let's look at one more example before we round up. It says, find the time taken by a person in walking along the boundary of a square field of area 40,000 meters squared at a speed of 4 kilometers per hour. Let's go again. It says, find the time taken by a person to walk round a square field of area 40,000 meters squared at a speed of 4 kilometers per hour. So first we have a square. Right there we have a square, and the area of this square is 40,000 meters squared. Okay, but obviously we know that the length of the square will be equal all around. So you have L there, you have L there, which is length like that. And the formula for area, you remember, is length squared. Okay, so it means that if we can find the length, we just square it to get the area. But in this particular case, we are given the area to be 40,000 meters squared. So it would imply that 40,000 will be equal to L squared. That is length times length, which is the area, is equal to 40,000 meters squared. And then, of course, we'll find the square root of both sides, and L will be equal to 200 meters. Okay, so it means that this square is a 200 meter by 200 meter square. So we can get rid of the L and just put in 200 meters. So we have this square right here, and we are told that someone walks around this square at a speed of 4 kilometers per hour. So the person has to walk around the square. It means that he has to walk the entire perimeter of the square. He'll walk the length and the breadth, and then the length one more time and the breadth one more time, just like that. And so what's the formula for the perimeter of a square? That would be 4 times L, because each side is the same length, so you just go around it 4 times, and that'll give you the perimeter. So perimeter of a square is 4 times the length of the square. We know the length of the square to be 200 meters, so 4 times 200 meters will give us the perimeter, which would be 800 meters. So it means that if someone walks around this square, the person would have walked 800 meters. Okay, but this question tells us that this person is walking at a speed of 4 kilometers per hour. Now, since our perimeter is in meters, so we'll just convert our speed also to meters per hour. So the speed 4 kilometers will be 4,000 meters at 1 kilometer to 1,000 meters. So we have 4,000. The speed is equal to 4,000 meters every single hour. So the person will walk 4,000 meters every single hour. But then he doesn't have 4,000 meters to walk. He's walking around a square field of 800 meters. But we know the formula for speed. Speed is distance over time. So it means that the speed, which is 4,000, is equal to distance, which is 800 meters, divided by the time that it will use, which is what we're trying to find. So you cross multiply right there and divide both sides by 4,000. So your time, which is t, would be equal to 800 divided by 4,000. And then 800 goes here 1, it goes there 5. So it means that the person will spend 1/5 of an hour to go around the square. 1/5 of an hour. But then so that we can make that appear more reasonable, we know that an hour is 60 minutes. So let's just convert to minutes. That will be 1/5 times 1 hour is 60 minutes. So we have 60, and then we'll divide these by 5, and the final answer will be 12 minutes. So this person who walks at 4 kilometers per hour will go around the entire perimeter of this square in 12 minutes. All right, and that is really very easy. I hope you understand that very clearly as well. All right, so this is all the examples, or these are all the examples that I have for us today, and I'm gonna leave you with exercises. I'm gonna leave you with exercises that you will be sending into the emails on your screen as well. There are okay, so you see 1, 2, 3, 4 of them. Is that so? Or 5? Yeah. So you just attempt these. There are 4. You attempt these exercises, okay, and then send in your answers. Make sure that your work is written boldly and in legible format, so that it can be easily seen and your logic can be easily followed. All right, so that's the end of today's video. Thank you for your time. I hope that you have a very good understanding of this concept already. And the next time we are going to be meeting, we'll be going into other areas of mensuration. All right, so have a wonderful time. Take care of yourself. Bye-bye.